So moving on, the structure, as I said, we will first introduce our panelists, and then we will move on to a Q&A session. This webinar will have a duration of approximately 1 hour. So I will stop sharing right now and moving on. So we will start with introducing our panelists. So I will start with John O'Brien. John, welcome to today's session. If you could introduce yourself a little bit, get to know a little bit your background, please.
Afternoon or good morning. John O'Brien. I work at Private Energy Partners, helping out the Quinbrook family on storage-related matters. I've been there for 2 years, looking at kind of all aspects. Most of it is shorter duration, but with an eye towards the future, which has some possible long duration in with it. Prior to Quinbrook, I was at Siemens for 14 years in their project finance team and did 4 standalone projects kind of for the first kind of 5 to 10 finance projects in the United States around the kind of the more standard lithium ion 4-hour storage.
Okay, well, thank you so much, John, and welcome. Moving on, Kate Sherwood. Hi, Kate. Good morning for you, right?
Hello, Kate Sherwood, president of Green Blue Energy, a consulting firm focused on supporting renewables and energy storage and related companies in growing their businesses. Thank you.
Thanks, Kate. Next, I have Prateek Saha from Black & Veatch. Hi, Prateek. Good morning.
Hi there. Good morning, everyone. So I'm Prateek. I'm a consultant at Black & Veatch, and I specifically focus on developing energy storage, low carbon hydrogen, and carbon capture projects. And I guess for this particular LDES webinar, what is relevant, another relevant information is that I'm also working the technology validation Tiger team for the LDES consortium led by Sandia National Lab. Nice to meet you all. Bye.
All right. Well, thank you so much, Prateek. Next, we have Kara Rodby from Volta Energy Technologies. Hi, Kara.
Hi, thanks for having me. I'm Kara Rodby. I'm a technical principal at Volta Energy Technologies. We are a very thematic venture capital firm. So we're investing in, new companies commercializing new tech. We're specifically focused on energy storage hard tech, but that encompasses kind of anything related. My particular background is focused on kind of long duration energy storage technologies like redox flow batteries.
Well, thank you, Kara. And last but certainly not least, we have Sherif with us from Storlytics, our knowledge partner for this event. So hi, Sherif. Good to see you.
Hey, Christina. Great to see you again. So yeah, I'll go ahead and introduce myself. So Sherif Abdelrazek, co-founding CEO of Storlytics Energy Storage. So what Storlytics is, the best way to describe it is it's the PV-SYST of energy storage. So a modeling and software platform to help developers and engineers design and optimize the design of energy storage projects. Formerly, I was the director of energy storage engineering at Duke Energy, where myself and my team were responsible for the design and optimization of more than 1 gigawatt hours of energy storage projects in 6 different U.S. states.
Great. Well, thank you, Sherif. Well, thank you, everyone, for your introduction. So now moving on, we do have a couple of pre-submitted questions. So the first question goes to everyone. What are the primary problems that you have encountered when talking about financing LDES technologies?
Yeah, thank you. I think about this in 3 ways. Number one, it's really hard to finance a new technology. Some parallels can be taken, and I'm happy to talk about it from other industries. I would not propose direct parallels with the short duration or up to 4-hour energy storage industry right now. But this is hard. So if people are trying it and you're finding challenges, it's because it is. I think the challenges with financing is the financial backstop from credit-worthy entities, since so many entities are small startups that potentially Kara's team invests in and John's team invests in or looks at. The backstop needing to come from a credit-worthy entity that may require investment in the short term or near term from places like the government, in the US government, for example, from grants and incentives from the IRA of 2022. And related to that, then the third point is that geopolitical considerations may affect where governments invest. The US government doesn't love that so much of current short duration technology comes from China. And so there may be an opportunity to, at least in the US here, to propose that domestic sources of projects and of technology, need domestic investment, may be a way to get things like the US government to invest. So it's hard. You need money from a credit-worthy entity, and geopolitical considerations may affect what entities want to invest where.
Okay, thank you, Kate. Does anyone want to add to this question, or did Kate answer everything?
I think the two big keys, kind of technology question aside, on long duration, it's right. It's the financial backing, and it's kind of distilled down into two factors. One is warranty, and the other is sustainability of the company in a true financial sense, not ESG sense, because you'll never get anything financed if it's a first of its kind or a second of its kind without a proper warranty backing it, maybe even third or fourth. And so you'll be looking to either have a company that has the financial backing, so you'll probably trend more towards a flow, let's just say a flow battery at that, let's just say Lockheed has, or a long duration that may get under the fold of someone with a real balance sheet behind it, rather than a startup. But then the other important point is, if you put a project down, even if you can survive the warranty claims, if 5 years from today, the company just kind of disappears and you're kind of left on your own without any real backing. And that's ultimately, to me, that's my main concern is, I may have the best technology, but you may pick the Beta instead of the VHS, but eventually you won't be able to repair that Beta machine, or you won't be able to get tapes for it. Even though it's technologically superior, the financial backing will papers over a lot of those issues as well. So I think, to me, that's kind of the main concern, is what's the staying power of that company.
Thanks, John. Prateek, I think you want to say something? Yeah.
Yeah. So I agree with Kate and John in general. And I'm talking from my background I've worked in about close to 10 LDES projects right now. And I'm defining LDES project by any energy storage project, which is 8+ hours of duration. It depends on your definition too, but let's just decide on that for now. So the first thing that we struggled with while developing projects is if the technology provider, the LDES technology provider, is bankable or not, right? So are they going to stay in business in 5 years? Have they been tested thoroughly? And that is one. So I agree with John and Kate, but there are a couple of more points that are also important. So one thing that we struggle with is which technology to go for, right? See, when we try to develop a lithium-ion battery project, it usually boils down to which vendor you will go to. But the product they offer are kind of technologically similar. Obviously, there are differences in offerings, the software and how it interacts with the grid and all those things. But in LDES, it's even deeper, right? Because you can choose either electrochemical technology, you can choose a high temperature technology, you can choose a thermal storage, you can choose a mechanical storage, you can choose a gravitational storage. So what you will go for? So I think before even choosing the vendor and everything, it's also about your strategy. Say, for example, if you are in a location where you have depleted salt caverns, we usually start from, say, a compressed and air energy storage, because we can use that existing facility to lower down the cost, even though it has low round trip efficiency. So that is one. The second, another struggle we have with the long duration energy storage technology providers is that the way they provide the performance characteristics of their product or the solutions is not enough. So, for example, the flow batteries will say that, oh, our solutions will last for 25 years. But they don't say what C rate are they using, say what charge-discharge rate are they using, what temperature are they using for it? Like, can we actually use a flow battery which is liquid in, say, a place like Alaska, right? If that is the case, then do we need additional thermal management system? So they don't provide those fine metrics that are very, very important in developing a project for a particular region and for a particular use case. So I think we have been recommending the technology providers to provide as much metrics as possible so that we can design the project efficiently. So I just wanted to add these two more points to what Kate and John already said.
Yeah, I'll just chime in here real quick. I think you're spot on, Prateek. What you see from long duration energy storage OEMs and really for all battery OEMs in general and technology providers is they will rate their technologies at the best possible conditions. If it operates best at low temperatures, what you find on the spec sheet is its performance at a lower ambient temperature. And that really, really complicates things because even if we had data sheets that were at a common like standard temperature and pressure condition, the effectiveness and the performance of any energy storage technology highly depends on exactly how you're going to dispatch it, right? So one of the things you mentioned is C rate, right? So C rate is definitely an important factor, but additionally, how long do you spend between a discharge cycle and then a charge cycle, right? What's your depth of discharge? So really at the end, what you find is the data sheet really doesn't tell you that much. Again, even if they were all kind of standardized to common conditions, unless you take into account exactly your use case and how you're going to dispatch your system.
Kara?
Sure. I mean, I think implicit in you're asking, about challenges to financing. I'm coming from a little bit of a different perspective. I don't finance projects, but I invest in startups. But, implicit in your question is the assumption that there are projects to finance, right? And so I think from my perspective, when I'm looking at investing in startups, a big challenge for us is predicting and understanding the market timing and readiness for a broader scale demand for long duration or varying amounts of duration, right? If we want to break up that category into parts more, I'm sure we'll get into that throughout this discussion a lot more. So I won't go deeper into that. But for me, a lot of the consideration is the market timing and readiness. I would say my hot take, or I don't know how hot it would be, but is, I do think a lot of these technologies, while they have not been demonstrated and proven to the level of lithium ion, for example, I think they technically will work and can work and are, can very understandably work. Obviously they have to demonstrate a little bit more before they can get financed by some of, the other folks on this call. But, I'm not as worried about that piece as I am how these companies evolve, how they're able to get customers early on and create a business and reach, the actual costs and performance metrics that they are projecting. And then the broader market demand and need for long duration, the timing of that, the magnitude of that. And then beyond that, kind of differentiating as was alluded to earlier, the kind of really vast array of options in this space, differentiating amongst what I would say is a lot of options in a very similar capital cost and round trip efficiency space. Those are all challenges for me from a venture perspective.
Okay, perfect. Well, thank you everyone for responding to this question. We have a next question that Sherif pointed out that he wanted to answer from the audience. And I think it's really important because it's a question that everyone talks about, right? Which is the definition and length of long duration. Where is the dividing line between short duration and long duration, and where might it be 3 years from now? I think that's a really good question to kind of continue because there's no right or wrong answer. Everyone has a different take on it. So Sherif, if you would like to start telling us your opinion.
Sure. Yeah, it's a really good question. And I'm sure everyone on the panel here, it came to their mind that at some point, where is the dividing line? What we have noticed most commonly is that the term long duration energy storage technology has just come to apply to really any technology that exceeds the duration that lithium can handle. When you look at kind of the limitations on duration for lithium, you'll find that in one part, it's a financial limitation, right? When the duration of the system become like going to 6 hours, 8 hours, become financially unbearable because the cost of battery cells or lithium battery cells mostly tied to the energy capacity within, not so much power. The other part is that the short circuit current of the lithium systems, right? How much energy can you pack behind a single DC bus. What we have seen kind of on our end is you start getting issues at greater than 6 hours. We actually implemented a project, a lithium project that was at 6 hours duration. So I've come to define that threshold as 6 hours where, I've seen kind of lithium be able to get executed.
Okay, great. Does anyone have a different take on the length of long duration? Because I know it depends a little bit on who you're talking to. People will say 10 or 12 even. Yeah, but thank you for that, Sherif. All right, so moving on. So as we've seen the challenges from each and every one of you and having different backgrounds, what initial steps do you think should be prioritized in formulating a framework to facilitate investing in these projects? John?
I think Kate was going to jump on this too. It's not really a framework for investability. It's a pathway to making money off of these projects. And I'm not even talking profit. I'm just talking even money because, I think to the last question, I don't think it's necessarily relevant to break things down into short duration or long duration. It's really what is applicable to the market these days. And that's twofold. One is kind of the wholesale market, and that very much rewards things depending on which one you're in, 2 hours to 4 hours, but a lot of the 4 hours is mandated, and then anything longer than 4 hours, which people will throw into the bucket of long duration, that's really just mandated by the government and put in by the utilities. So a lot of what we're seeing today is really utilities getting in and doing their kind of their pilot projects for any particular type of technology. So it's, not really even a financeable market per se, because you need to have, a market signal to allow third parties to enter. And that doesn't really exist today. Maybe it exists 5 years from now, but, at this moment, and I think where that all kind of comes together then is kind of where Kara comes in. It's, do you invest now for something that's not going to hit until 7, and what's your crystal ball on what the need is going to be? Is it something that has a footprint of 20 acres to get you, 100 hours, or is it something that's 2 acres and get you 10 hours? So those are all kind of the nexus questions you have to ask today, but it's still kind of undefined because there's no pathway to actually making money and not losing money.
I agree generally. I think, it does relate quite a lot to the last question of, I tend to agree. I don't really care to delineate so much on the hours. It's just what makes most sense cost effectively. And I think, creating different, pricing markets, all electricity markets, that's not my area of expertise. But I think, right now it just doesn't, it doesn't make sense especially in an environment with such a low cost incumbent. Back to the duration question. LFP is just so cheap right now. And I think, as Kate mentioned, not just geopolitics, but just pure supply chain constraints. As that evolves, perhaps that landscape will change and start favoring some of these more abundant materials. But, without better incentives, it's just hard to make these newer technologies that are produced at much smaller scales be cost competitive with other options.
Yeah, Christina, can I add to what both John and Kara said? The market today for long duration starts to look like the market for other non-storage technologies. Natural gas is highly financeable and been around for a long time, very traditional thermal energies. So if energy storage, part of its value is its sub-second quick ability to provide electrical infrastructure support, that's on the extremely short end. So what's the value that long duration has versus the incumbents? Where technology has changed over time, it's where it's cheaper or it truly is better. And right now there's not a lot of incentive, as John mentioned, maybe other than some government incentive. Some utilities are having to invest in energy storage longer than 6 hour duration, but there's no financial market incentive that provides it today. And then to the technology, we go back to the financeability and creditworthiness of the entities. So it's fairly challenging to make long duration valuable. Again, government support seems very important. And I don't see a lot of specific long duration support being announced today. Maybe there's lots of applications in. But yeah, I think long duration energy storage takes away or does not highlight some of the inherent benefits of the short duration energy storage, which provides a variety of different use cases. So maybe I'm sounding a little down, but I think on purpose, this stuff is hard.
Thanks, Kate, for sharing your insight. But yeah, definitely. Prateek, you want to say something? Go ahead.
Yeah, just to add to other people's comments. You know, I was trained as a hardcore electrochemist. And when I was doing research, we don't know what the utilities look for in a technology. Like, right, the way they rate a technology is very different than the way we used to rate a technology. So now having about a year of project development experience, energy storage project development experience, what I would like to see a lot of investment in testing those technologies. So what I would recommend the technology providers to partner with, say, national labs like who are working in LDES space. For example, Sandia is one, LLNL is one, NREL is one, EPRI is one, and have the products tested in the relevant conditions that are relevant for utilities or commercial space. So we are talking about C rates, temperature, and also like what Sherif was mentioning, the idle time, the short circuit current, and all those things that can actually make the technology, like from the project development perspective, that can make the technology more bankable, more reliable. I'd like to see more and more investments. Now, definitely, US DOE has this long LDES shot, and they're funding some pilot projects. But I'd love to see more investments in the pilot projects.
Okay, well, thank you for that. Oh, Sherif, you want to say something? Go ahead.
Yeah, no, I think the point that Prateek put is really, really good. One of the outputs of these pilot projects and, not just pilot projects, but also lab testing is the data, right? There's definitely a need for this testing, but it definitely gets expensive. So when you actually do embark on it, you want to collect as much data as you can to get to a point where you can actually model the technology so that you can kind of test its suitability and effectiveness performing the million use cases that are out there that are different from one market to another, one utility to another, that varies by the location because of ambient temperature. So I think definitely, a lot of testing is needed, but in addition to that testing, platforms to actually capture all these characteristics, because having these characteristics on paper is one thing, right? And then if you talk to any utility today, or the specifically the battery team within any utility today, and we've had those conversations, and I have a utility background. They talk to 1 million battery technology manufacturers, long duration technology manufacturers, and they have a million data sheets, and it's almost impossible to put them side by side. So being able to capture that data, transforming it into very accurate models, like what the solar industry has already done and figured out by, I think PVSys kind of pioneered, the PAN files for solar modules, which were very, very expensive 10 years ago, and gave a very significant importance to that level of detail in modeling. So I think we're definitely in a similar place currently.
Well, I'll talk to you for depressing there, Kate. I'll argue that we can do all that testing, and at best, the second best technology will be the winner. That would be my prediction. Because you've seen it countlessly. Technology that makes a ton of sense. Once you get to the point of how do you manufacture it, you have working capital and you have inventory at risk, that becomes very burdensome very quickly. So, I think you're going to have the best mousetrap out there, but it may not be the winner, right? So I think there's a lot of other factors outside of technological that I think will end up leading the way. I think solar is very much, a very standardized product, whereas as we mentioned at the very beginning, there's so many different outcomes and technologies and chemistries with alternative technologies that, it's just not one person will lead the way. One person will lead the way for themselves, not for an industry, I think, at least on the technological side.
Okay. Well, thank you. Sherif, you're not on mute. Do you want to say something or?
Sorry, I forgot it.
Okay, that's fine. Okay, well, moving on to one of the questions from the audience, Will McNamara. Something important is what do we need to make these investments happen? And one of his questions is what enabling policies for LDES would you like to see either at the state level or through RTOs or FERC? What is needed policy-wise to kind of facilitate the process? Go ahead, Kate.
Yeah, I think in the short term, let me first say, I'm not sure that I would like to see this. I think what is important or necessary for more LDES adoption would be the continuation or expansion of like what California has done with the RA or resource adequacy payments. Because of the way the solar market is there, they have resource adequacy contracts and payments that, again, are financeable themselves. So I think, a compensation mechanism to reward the longer durations is, again, I'm not sure I like it, but it's important if LDES is to be supported as a new technology. This has to be paid for somehow, customer fees, something. It's got to come from somewhere, but I think that is necessary. I use the California resource adequacy example. I don't know, or I myself based in ERCOT, so I don't believe that's the only mechanism possible. I think there's lots of other incentive mechanisms, but that's the type of thing that I think is necessary. So it's that policy, the providers themselves dropping their prices by, the DOE would say, U.S. Department of Energy would say 50%, half, dropping their price that they sell at and increasing their round trip efficiency. So the LDES batteries, the actual physical technology, has to come up by at least 10%, 15%. All have to happen. So.
Yeah, and I think also, Kay, I think the policies are there. It's just, I don't think anyone is really confident that it has the teeth. So, right, every state that has a 100% or 75% renewable mandate is fertile ground for long duration storage to bridge you through that overnight, or else you'll be stuck not at 100%. So what the states are going to need to do, as they've done with some of the renewables, is how do you bridge and send the signal today that, let's just say by 2030, you need renewables. So, most of the United States, you've got a lot of competitive markets out there, and, it always causes problems once the states get involved with mandates and procurement. But I think that may be the only way to kind of bridge that gap to get people comfortable enough to invest in long duration is by having the states with the mandates to show that they really are serious about it by procuring the long duration today.
And I'm sorry, John, do you mean through the state-run or through state-funded utilities like Sherif used to be with Duke in North Carolina? That's not state-funded, so through the PUC funding, or I'm just curious how you might see that.
I'm thinking things like NYSERDA, right? And that's the easy one to think of because, they have New York has a 2030 mandate. NYSERDA is out there throwing lots of money around, especially at storage and creating mechanisms to encourage it. But, there are other states out there too that have storage mandates that are trying to achieve this, whether they're storage mandates or renewables, but it would be some sort of PUC level type payment.
Okay, perfect. Shall we? Oh, sorry, Prateek, I didn't see you there. Go ahead.
Just one quick point. I don't work too much with the policies or incentives, but I think we already have the tax incentive in place, right? The investment tax credits that usually the lithium-ion battery projects usually use. I think it should be available for LDES too, right? Because at the end of the day, it's an energy storage plant.
Yep, and I'll just add here. So we had kind of incentives down in Florida at some point, and we supported a project to vet, I want to say, about 6 to 10 long duration energy storage technologies and they were candidates for this project. What we found is that almost all the technologies we vetted were either not at a point where they're at the level where they can execute a pilot at the scale that we were at, or they were just prohibitively expensive. On both points, they were contradictory to what these technology providers were kind of advertising for their technologies. At the end, we went with a sodium sulfur technology, which really isn't that new. Some would argue even if it's considered a long duration, but that's just another point to be mindful of, the technology readiness level of the different LDES technologies out there. Some are more advanced and more ready than others, but a good percentage is kind of lacking and needs support.
Okay, thank you. All right, well, moving on to the next question that is also coming from the audience. It's about technology and how to select the appropriate technology. So the question comes from Mariola, and Sherif, if you wanted to answer this one. So the question is, what metrics should be considered as crucial for choosing LDES behind the meter applications? But I wanted to kind of broaden the conversation into general. How do we choose a technology, which is one of the other challenges that we can find?
Yeah, absolutely. It's a really good question because, and you, who asked the question, Mariola, I think, referenced behind the meter, right? That's certainly a consideration, but another very important consideration is the dispatch profile, how exactly your system is going to be dispatched, whether it's behind the meter or in front of the meter, is really, really important. And I'll just give an example for the audience here. So for a use case in which you're kind of heavily cycling, you're charging at different rates, you're running your system really hard, a lot of throughput going in and out, you're probably going to need to care a lot about, or not probably, you will need to care a lot about cycling losses and round trip efficiency. And self-discharge it's probably not going to be that important to you, right? You're also going to want to focus on cycle degradation, right? Because you have a use case in which, you're heavily cycling your system. So, that's going to be very impactful if you're working with a technology that degrades more with cycling per unit energy throughput, right? But for another use case in which for example, backup power application or reliability improvement application, in which you're charging your system and then waiting for an outage to happen to discharge and meet kind of critical load. For an application like that, then in that case, self-discharge is extremely important because you're spending the majority of your time just waiting for an event to happen. That is, of course, unless you're stacking other use cases. And in that case as well, you're not really concerned about cycling losses or RTE because your battery is just going to sit there. So you should not be surprised to learn that a lot of UPSs, right, that operate like this rely on basically car batteries, right, lead acid batteries. Very, very old technology, but it's great at keeping a charge, not a lot of self-discharge. So they work well for that type of use case. So, to sum it up, the dispatch profile is paramount. I'll add to that the project location and MET conditions. A lot of the long duration technologies that are out there are very, very susceptible to temperature. Like at 20 C, you'll get, let's just say almost like 0.5% per hour in losses. That's just sitting there. But if you go to 30 C, you'll get like triple that, right? So ambient temperature is really, really important. So, and in turn, project location. So I'll just leave it at those two.
Can I add to Sherif and give a quick shout out for his firm? Modeling this is really hard. the available technologies, I'll say beyond Storlytics, someone connect with him if you want, but no, quite seriously, when I was in the project development space with Wärtsilä, we used like 15 different spreadsheets to come up with a project model for one use case. And the way that the warranties, to reference what John mentioned earlier, the warranties from the energy storage providers of short duration made a broad assumption, one full depth of discharge per day. So if you if you wanted a scenario where you wanted to do multiple different use cases from the same technology, from the same battery, the engineering assumptions were either not available in the 15 different spreadsheets that had to be combined, or wrong for the use case that the customer was requesting. So I think that's why Sherif has a business, but quite seriously, this modeling this even relatively accurately is hard. And again, that then adds to the financeability challenge that John mentioned. So the KPIs do come from the use case, but the data may not be there. And Sherif, maybe you can say if the data is there, but from the manufacturers and the warranty providers to make any meaningful output and proposals from them.
I just add a quick piece of color to what you said there, Kate, on the warranty too, and the degradation and the broad swipes. Yeah, that is actually very important, especially when you're reviewing the technical aspects and things like whether it's merchant, how much you could put on the grid, but then also when you need to augment. And back in the day as lenders, everyone would kick it back to who knows the technology the best, and that's the OEMs. And then what is being presented under the warranty is generally what is accepted as you run the case, you set the parameters under your market and your market consultant case and dispatch case to 1C, and then you use the warranted degradation curve, right? And it maybe is probably better or worse, and in a lot of ways, a lot of success in batteries is that the warranty is just too conservative. But that's to put a point on it, that's another reason why you need to have a well understood warranty, which is something to look at for the long duration, is that the financing decisions is a lot of them are driven off of that warranty curve, for better or worse.
Yeah, I think the warranty curves are definitely helpful to kind of give you that assurance for definitely established big players out there. But I think one of the Achilles heels for long duration energy storage technologies is that I think probably aside from Lockheed Martin and Honeywell, right, for flow systems, most of the companies are startups that are not bankable, that their warranties aren't really that honestly important, right? You can't rely on them. So, and even if we kind of talk about like the warranty covering or being a data point to provide you with a viewport into the characteristics of the system, it does not allow you to be able to compare between different technologies and their suitability for your use case. So that technology selection optimization isn't really, you're kind of crippled if you're relying only on performance guarantees. And let's be realistic. For the most part, performance guarantees, they just look at degradation. But we're seeing a lot of developers today notice that their projects are consuming much more energy than they anticipated, because not a lot of OEMs out there provide guarantees on HVAC losses or HVAC load in general, right? So for cooling, if the technology requires that. So I think definitely a lot more testing and data is needed on the front end to move this industry forward.
Prateek, you wanted to say something?
Yeah,
go ahead.
Yeah. So to add to the previous speakers, actually. So what we learned while developing, the long durations energy storage projects here is that we even start from a higher level, right? So the first question we ask is, I think Sherif kind of mentioned it, is like, who is deploying it and what is the purpose of it? So I'll give you some examples, right? What we found is that for commercial entities, like say, for example, data centers, right? Or say an Amazon warehouse. They are their first constraint is space. You don't have a lot of space, right? So they usually go with the technologies that are more energy dense, and they tend to be electrochemical technologies. So it could be, high temperature sodium sulfur battery or something like that, but they usually go with, in that case, the technology space, automatically you start with a smaller subsection of technologies, right? So that's easier. When you say, for example, when we work with industry, so a manufacturing plant that has a lot of waste heat. So for example, ammonia plant is an example, methanol plant is an example. When they look at a backup, say a long duration, say 8+ hours or storage system, for them, we consider that, okay, what are the systems where we could use the waste heat to increase the overall round trip efficiency of the process? So we tend to go towards high temperature systems, either thermal storage or, for example, the high temperature batteries. For utilities, it can get really complex because, first of all, they own assets in different geological locations where the geology comes into the consideration. We have seen cases where, say, an utility owns a location, they're sitting on top of a place which has a high geothermal potential. Then we usually don't recommend any energy storage at all. We just recommend that you go with enhanced geothermal. We have seen locations where pump storage hydro would be a best option. Although the US is not such a case. We haven't seen much cases. Usually we have seen that for cases where the dispatch profile is such that they can go for like either one full cycle or maybe like less than one full cycle, so like 50% of the usable energy or something. We recommend, for example, flow batteries. So there are a lot of cases that have to be considered, but we usually take from like a higher level and go with the policy, like the strategy of exclusion. So consider all possible sets of technologies that you could start with, and then based on your location, your use profile and everything, then start excluding the technologies and get down to maybe 1 or 2 or 3. That has been our strategy to choose the right LDES provider for a certain time.
And I think as a kind of an aside to the original question, but just on the thread of what we've been talking about, I think there's a nugget in there, which is that, differentiation amongst the LDES space, I think is something that's maybe needed to be understood more and explained more and kind of put forward more. There was a comment earlier about how a lot of the LDES commercial entities or those pursuing being commercial entities are startups. And I completely agree. Not only is it startups, but I would go as far as to say very academic oriented startups. I think, the majority of this LDES movement has started out of academia, and part of the, and that's common in energy venture, I'd say. But, the challenge with that is that you have teams that are a little bit less commercially experienced and oriented. And I think a lot of times that challenges their commercial traction. It challenges their communication in kind of these topics in terms of like, differentiating themselves in a very broad space of LDES. And that could be something that could be worked on better. And, I think that is, from my perspective, one of the reasons like Form, for example, has had relatively more success than others. We could debate the validity of its tech separately, but just how have they raised so much money and gotten so much, initial commercial traction, I think is because they do a lot of in-house modeling and they're able to explain to customers and demonstrate to customers why you would need 100-hour storage or whatever it is, right? And I think that's that's maybe a learning lesson for other startups in the space.
Okay, perfect. Thank you. So moving on to the questions from the audience, there's a question that Kate would like to answer from Ken Hoffman. He asks the following question: how do LDES technologies such as flow batteries compare in total cost of ownership over, say, 20 years compared to LFP? Many flow batteries do not require augmentation, thus should be more cost effective over a long period of time.
So yes, that is my understanding as well from the models and the information I've seen. And I'm going to go back, I'm going to repeat what John said again. It's about the warranty and who's backing the warranty. So if it is one of the named companies, Sherif, that we all recognize, that Sherif mentioned, then yes, the warranties are probably worth something. And if the batteries do not degrade faster or do not suffer problems, then the total cost of ownership should be lower. But you have to put a risk premium on it for any company that is not financeable today. So, and I'll let the financiers in the audience or in the speaking group talk more about what that risk premium should be. But I would say it is non-zero and more significant. So I'll let my fellow panelists answer how much risk premium might be necessary for smaller companies.
Yeah, and I'll add a point here. So I think it's really relevant. We did a benchmarking analysis with Enervenue 2 years ago in 2022. We benchmarked it against lithium LFP for a 20-year application. For those of you that are not familiar with Enervenue, it's an eco-hydrogen technology. Its biggest advantage is that it has very high cycle life, 20,000 cycles to 30,000 cycles compared to lithium, 8,000 cycles on a very, very good day, but has lower round trip efficiency. So all the technical details aside, we put everything kind of beside each other. We set the use case, and what we found is it was more advantageous and from a cost of ownership standpoint to use that technology for a 2 or more than 2 cycle a day application over that 20 years, because the cost of lithium really went high because of augmentation and or overbuilt. And I think the point that Kate mentions is really valid. Well, what about the warranty? Now, should you actually execute that project with that Enervenue relying on its warranty? In that case, you don't necessarily have to worry a lot about the bankability, because the technology itself, if you do a little digging on it, it's not that new. They just enhanced it to the point where they got it to be cost bearable. It had titanium in the cathode before. They replaced that. I'm not an electrochemist, but long story short, they improved the cost and without losing the high cycle life characteristic. So that kind of defers a little bit, worrying about the bankability of Enervenue as a new company in that case.
If I could add too, yeah, I think, implicit in the question about total cost of ownership, right, is kind of a differentiation between like a lifetime amortized cost, total cost of ownership, as you're mentioning, and the upfront cost, right? That's kind of like the two things we might talk about. And so, yeah, I definitely believe there is a plausible argument that a lot of these long duration technologies can be more cost effective when you take into account the lifetime. The problem is one, not every application values total cost of ownership as its primary, market financial mechanism, right? Like that's not always the primary earn. And certainly in this case, yes, I think in general, grid use cases do value the lifetime, but these are also very big projects. And so the upfront cost is going to be a barrier first and foremost before you can even really get to considering total cost of ownership. And that's the problem of where we stand today, is that these, it's many startups putting out these technologies at a very small scale. Lithium ion has had the benefit of, of much higher value beachhead market, time, scale, et cetera. And it's just hard to not just compete on cost, but even come up with a believable path to achieving cost. How are you getting sales and customers when you're still at a higher cost? And how are you getting down that cost curve with scale, with learning, with time? That it's a harder story to understand when you're selling into a margin constrained market. So I think that's part of the consideration. Yes, it can make sense on a total cost of ownership perspective, but that's not, there are other barriers and other considerations that matter too, and that's the problem.
So to clarify, Kara, when I say overall cost of ownership, that's including the capital cost, perhaps not the correct financial term. Forgive me, an engineer here, but that's including the total, both the running cost and the capital cost. And for the audience, you can review the results of that analysis. It's really in depth. It's actually on Enervenue's website, kind of side-by-side comparison for a 20-year project.
Yeah, can I just add one quick point to this? I agree with what the previous speaker said. So this question came up in it's just like a side note. I agree with what you all said. Is like, what metrics should we actually consider to compare different technologies, or even if the flow battery, should we consider the vanadium or iron chloride or whatever we have, nickel, or even nickel hydrogen or something. And people expressed a lot of doubt on levelized cost of energy as a metric. First of all, I mean, the value you end up with will depend on your use cases. So we all agree that there should be a flexible techno-economic model that can take into account the particular use case and that can speed out the levelized cost of energy for that particular use case. And I guess that cost of ownership will come out as a corollary of that calculation. That's the first thing. Another thing we also have been seeing that, it's actually based on the discussion on the warranty. We have been recommending the technology providers to come up with some sort of long-term service agreement that we are seeing very common in the lithium-ion industry. That given an energy throughput, given a number of cycles per year, please provide some sort of performance guarantee. Unfortunately, some flow batteries we have seen that we are moving in the direction, but not other technology providers. That could be one recommendation from a project development perspective.
Okay. Well, thank you very much. John, or you're good?
No, I'm fine at this point.
Okay, perfect. All right. Well, thank you on spot. Our time's up. I know that there were tons of questions pending. How we'll send these questions to all our speakers. Thank you so much for joining us. Interesting. The issue is that we didn't have enough time for all the questions. But the good thing is that we'll keep having more webinars, and we'll be probably answering all of these questions that the audience has asked. So I hope everyone has a great day or afternoon, and we will see everyone very, very soon. Thank you, everyone. Take care.
Thank you, everyone. Bye-bye.